Right, dear children, now we solve next problem, that is problem number 2, and this is also an important numerical, okay, which might ask in the examination also. Okay, and this is problem number 2, and it says that a drop of water, means a single drop of water of diameter 0.2 centimeter. So what is this drop, a single drop of water diameter? 0.2 centimeter. So I write down for single drop of water. Okay, now for single drop of water, so what is the diameter? Your diameter is given 0.2 centimeter. But children, I convert this centimeter into meter. So what I need to do? We multiply by 10 minus 2. 10 minus 2. So it is 0.2 into 10 minus 2 meter. Now once you calculate diameter, we calculate the radius. Now let me just write down the radius of this single drop of water. Let me mark by letter capital R. And the radius is just half the diameter. So radius is diameter 0.2 into 10 minus 2 and divide by 2. How much? 0.1 into 10 minus 2 meters. So this is the radius of that single drop of water. Now if this water has a radius, then it has a what area also, and this area is called surface area. So I write down now, first calculate what surface area. Now I calculate the surface area of single drop of water. Single what? Drop of water. And this surface area of single drop of water, okay, is equals to 4 pi r square. Children, because drop is basically what in shape? Spherical in shape. And what is the surface area of sphere? 4 pi r square. That's why the surface area of single drop of water is also 4 pi r square. Okay. Now, after that, the question says that this single drop of water is broken up into how much? 27,000 droplets. What is the total number of droplets which is formed from this single drop of water? 27,000 droplets. And that droplet are of equal volume. What volume? Equal volume. So what is the total number of droplets? Number of what? Droplets of water that is actually formed from this single drop is 27,000. Okay. Now in order to make this single drop into 27,000 droplet of water of equal volume, we definitely have to do some amount of work, and this work we need to calculate. Means question say that how much work will be done against surface in the process. Means against what? Surface tension in the process. Actually it should be surface tension in the process. Now we do the work against the surface tension in the process, and this water surface tension is also given. So basically we mark by letter T, and surface tension of water is 7 into 10 minus 2 Newton per meter. So this is the surface tension of water, and you need to calculate the work done against the surface tension in the process. Okay. So in order to calculate this work done, children, so we calculate the surface tension which is already given, and we calculate the increase in what area? Surface area. But one important part you need to keep in mind, this single drop of water has a volume. So even when this single drop of water which has certain volume is broken into 27,000 droplet of water, the volume of single drop of water is same as the volume of 27,000 droplet of water. Okay. So with this condition, what I do, I calculate the radius of each droplet of water. Each droplet of water. Okay, drop of water means not a single drop, a droplet which is formed, that is 27 droplets which are forming, but I calculate the radius of each droplet of water. Okay, but what is the condition? As I said, the condition is the volume of single drop of water. Single drop of what? Water is equals to the volume of how many droplets which are forming? 27,000 droplets of water. Now volume of single droplet means usually the volume of sphere, and you know what is the formula of volume of sphere? 4 by 3 pi, and the radius which I have already considered is r. So that's why it is 4 by 3 pi r cube. The volume of 27 droplet of water is calculated as 27,000 into the volume of one droplet of water, and volume of one droplet of water is also spherical in shape. So that is given by 4 by 3 pi, but the radius that we don't know, so I consider that radius small letter r with q. So what is 4 by 3 pi r pi small letter r cube? This is the volume of small droplet of water. Small droplet of water. But there are total how many droplet of water which has formed? 27,000 droplet water. So I multiply by 27,000 to this volume. So these two volume are equals to each other. Now let me do the cancellation. These two cancel out. Pi and pi cancel out. Now see what is remaining. R cube equals to 27,000 small r cube. Now this is in r cube and this is also in r cube. Now 27,000 cube can also written in the form of cube also. Okay, but before that I'll make r cube as the subject. Small r cube, if I make as a subject, it will be capital R cube by 27,000. Yes, small r cube, if I make subject, this 27,000 will go in the denominator. So it will be r cube, small r cube equals to capital R cube by 27,000. Now to write this in cube, so can I write this way? Now see, it's r cube by 27,000 can be written as 30 whole cube, because 30 cube, see 30 cube means 27,000. 30 into 30 into 30, if you multiply, it will be 27,000. So small r cube now can be even written as capital R by 30 with whole cube. See, R, capital R also cube and 30 also whole cube. So I can put in whole cube. So it will R, small r cube equals to capital R by 30 whole cube. Now you know, in the case of exponent, when the power are same, the bases are also same. Which means small letter r equals to capital letter R by 30. Now you can see the radius of the what? Now you can see the radius of this small droplet of water, that is R by 30 centimeter. Now next part that we need to keep in mind, children, is even the volume of that single drop of water and the volume of 27,000 droplet water will be same. But what will not same? The area. The surface area of that 27,000 droplet of water will be more than the surface area of the single drop of water. So basically what happened, when that single drop of water is broken into 27,000 droplet of water, there is an increase in what area? Surface area. So I calculate now the increase in surface area of drop. So children, the increase in surface area of the drop, let me mark by letter delta A, okay, is calculated as surface area of 27,000 droplet of water minus surface area of single drop of water. So to calculate this value, what I do? I write down 27,000 into surface area of single drop of water. The single droplet of water means what? The formula is 4 pi small letter r square. Because 4 pi small letter r square is the surface area of single droplet of water. But how many droplet of water are there total? 27,000 droplet. So 27,000 into 4 pi r square minus the surface area of single drop of water, that is 4 pi capital R square. Capital R square. Okay. Now what I do, I'll take common in the expression. The common is 4 pi. So inside the bracket I'll put 27,000 and there is r cube, r square, sorry, minus capital R square. Okay. Now what I do, I replace small letter r by capital R. So in the expression you can see this is 27, sorry, this is 27,000 into small letter r is how much? Capital R by 30. Because we have already calculated the radius of small droplet of water is r by 30. So I replace small r by capital R by 30 with whole square minus r square. So let's simplify further. So 4 pi, this is 27,000 into r square by 30 square means now 900 minus r square. So this 0 cancel out, 9 1s are 9, 9 3s are 27 means 30. So it's coming now 30 r square minus r square. So this is 4 pi into 30 r square minus r square means 29 r square. So look at the increase in surface area of the bubbles. Okay, I mean the drop. That is 4 pi into 10 minus 4 pi into 29 r square. Now with this increase in surface area, I calculate the work done. Now I write down work done. Now this work done is nothing but surface tension increase in what area? Surface area. So delta A is the increase in surface area and we know surface tension. So we calculate the work done. So work done is given by W, surface tension, as you know it is symbolized as T, and surface increase in surface area means delta A. So let's calculate the value now. Now what is the surface tension of water? 7 into 10 minus 2. Now increase in surface area means this value, 4 pi into 29 r square. Okay, now let's substitute the value also. Now 7 4s are 28 into pi means 3.14 into 29. So I have done this multiplication into this is 10 to minus 2 into now r, capital R, and you know capital R value is how much? 0. Let me put 0.1 into 10 to the minus what? 2, and there is a square of this. Okay, now let's do the calculation. Now this quantity can be multiplied. Okay, now this quantity can be multiplied. Now before that, let me just write down 28 into 3.14 into 29. Okay, into 10 minus 2. Now 0.1 square, if you do, it will be 0.01 into 10 power minus 2. The 10 minus 2, 2 to the 4 means minus 4. Okay, minus 4. Now we can further multiply this 4 quantity. This 28, this is not 2.8, so this is 28, 3.14, 29 and 0.01. If you multiply these 4 quantities, we get approximately 25.5. Children, you can calculate by yourself also. Okay, into now 10 to the minus 2, 10 minus 4 means 10 to the minus 6. So 25.5 into minus 6. But this can be written this way also. Now I shift 1 decimal left, so it will be 2.55. Now if there is a negative power and if you shift 1 decimal left, then power decrease by 1. It is just opposite. This is minus 5. So minus 6 become minus 5. So finally your work done is how much? 2.55 into minus 5. And what is the unit? Joule. So how much work that is required to do, okay, to break that single drop of water into 27,000 droplet of water, that is 2.55 into minus 5 joule. So this is the explanation of problem number what? 2. Now we do 2 more numericals problem, okay, and that will learn in the next YouTube video.